Hi, in this video I'm gonna show you guys what is a unit vector. Okay, so the definition of a unit vector is simply a vector with a length of 1 unit, right, with a length of 1 unit. And by now we have come across 3 unit vectors. I'm not sure if you realize this. We have actually come across the 3 very basic and fundamental unit vectors. I want you guys to think about it. What are the 3 unit vectors that we have come across so far? Okay, I hope you have put some thought into it. The 3 unit vectors that we have come across are I, J, and K, right? Where my I is the unit vector for my x in the x direction, in the positive x direction, to be exact, in the positive x direction. Right. My J is the unit vector, the unit vector in the positive y direction, and my K is the unit vector in the positive z direction. Okay, so we have come across these 3 already. So if for example, if I have something that says my vector AB is equal to 3i plus 2j plus k, right? All that means is from my point A to my point B, I'm gonna go 3 units to the in the positive x direction, and then I'm gonna go 2 units in the positive y direction, and finally I'm gonna go 1 unit in the positive z direction, right? So I, J, and K, they're all unit vectors, and they are all 1 unit long, right? 1 unit, length of 1 unit, okay? In their respective directions, of course. All right, so now let's take a look at example, and you guys will have a better idea of how to find unit vectors. Okay. So here I'm going to use the example that we covered in the previous video. So we have 2 points. Point A is at 1, 3, 4. Point B is at 4, 2, 7. And I want to find a unit vector. Find the unit vector for vector AB. Okay. So find a unit vector for vector AB. So let's find AB first. AB is equal to, we did this in the previous video, so where we talked about the distance between 2 points. If you're not sure how to find AB, vector AB, please go back and watch that video again. So my vector AB is equal to OA, AO plus my OB, which is equal to, I'm gonna skip a few steps here, which is the negative of 1, 3, 4 plus 4, 2, 7, which is equal to which is equal to 3, negative 1, and 3. Right, this is my vector AB. So the question wants us to find a unit vector for the vector AB. All that means is, all we have to do is to find a vector that has a length of 1 unit, right? A length of 1 unit in the direction of AB, right? So all we have to do now is, since we already have the direction vector of AB, all we have to do now is to find the length, right? To find the length of this vector. So the length of AB is equal to, this is 3 squared plus negative 1 squared plus 3 squared always use a parenthesis, and that, if I remember correctly, that gives us 19, square root 19. So this vector AB has a length of square root 19. So if I want a vector, right, in the direction of AB, but with only one unit, this is, right now my vector AB is square root of 19 units long. If I just want one of them, one unit, so all I have to do is divide the vector by the magnitude, right? Divide the vector by the magnitude. That will give me my unit vector. Okay, so I'm just gonna say I have 1 over my magnitude is my magnitude. I have already found the length. The length is square root 19, right? And I'm just gonna use, and my vector AB is equal to 3, -1, and 3. And I can leave like that, actually. So this is my unit vector in the direction of AB. Okay, this is the unit vector in the direction of AB. All right, I want you guys to go over the examples in the textbook. They have easier examples because they in the textbook examples they used 2D scenarios, right? So here I'm showing you guys a 3D example. Okay. All right. That's it. I will see you guys in the next video. Bye bye. Oh wait, let me do a little bit more on unit vectors. Okay, so just now we have found the unit vector of your we've just found a unit vector in the direction of vector AB. Now how can we prove that it is actually a unit vector? All right, so I'm going to do this on the next page. Okay, so we now know that unit vectors have length of 1 unit long, right? And I have found this unit vector in the direction of AB. And let's prove that this unit vector, unit vector has a length of 1 unit. Because that's the definition of a unit vector, right? It must have a length of 1 unit. So this is my unit vector now, which means this is also equal to 3 over square root 19, -1 over square root 19, and 3 over square root 19, right? If I multiply this kind of 1 over square root 19 into my column vector, this is what I get. Now if I want to find the length of this, unit vector, then I hope you guys remember the distance formula, right? So this will be square root, okay, so the magnitude of my unit vector is equal to square root, actually that's not, this is, okay, oops, this should come down, okay, that will be 3 over square root 19, the whole thing squared, plus -1 over square root 19, the whole thing squared, plus 3 over square root 19, the whole thing squared, right? And that will give us, so square root 19 and squared cancels out. I will have 9 over 19. And for -1 squared gives us 1. of 1 over 19 plus, that will also be 9 over 19, which will give us square root of 19 over 19, which is equal to square root of 1. So therefore, my magnitude, or the length of this unit vector, is 1 unit. Okay? So this unit vector is in the direction of AB. Let me just write that down. So this unit vector is, number 1, in the direction of AB, in the direction of AB, and we have also proven that it has a length of 1 unit. Okay? Alright, I'll see you guys in the next video, for real this time. Bye.